All right, our next transformation is a reflection. All right, and if you think about it, have you ever noticed that when you look in a mirror, like a piece of jewelry, like your ring is on the opposite hand? Okay, so if you're wearing a ring on your right hand, in the mirror, it looks like it's on your left hand. Okay, it flips sides. Well, that's what a reflection is. So, a reflection, casually known as a flip, is a transformation over a line of reflection, like the mirror. Okay? Each point of the pre-image and its new image are the same distance from the mirror. Okay? Sorry, from the line of reflection. But think about it. If you're looking in a mirror and you back up, what does your reflection do? It backs up. Okay? And you're the same distance from the mirror as your mirror image is. All right? So, let's talk about some different reflections you might have. A reflection across the x-axis. Well, where's the x-axis? Right here. So when you flip, think about folding it over that line. So if you had this on an actual piece of paper, or you have it in your notes, if you wanted to, just take your paper real quick and fold it on the x-axis. You don't have to, but if you want to, you could. If you did so, this point would land on this point, and this point would land on this point. In class, remind me to show you a little game we used to play when I was a kid that worked on this theory. On the y-axis, well, we're folding across the y. So this point matches this one, and this one matches that one. Okay? Just notice what happens to the signs. Okay? 4, 1 becomes 4, negative 1, because they're both 1 away from the axis. 7, 3, 7, negative 3. They're both 3 away from the axis. Think about the concept of absolute value. Negative 3 and 3 both have an absolute value of 3. That's their distance. Over here, the x's, negative 2 and positive 2, are both 2 away from the y-axis. Negative 6 and positive 6 are both 6 away from the y-axis. Okay? Now, we're going to do one here that is not as easy to visualize because we're sorry, my bad. I'm getting ahead of myself. Silly me. So we're folding this across the x-axis. If I would just read, I'd be fine. Now, notice what's interesting about P. P is on the x-axis. So it's going to stay on the x-axis because what's its distance from the x-axis? 0. So the reflection is going to be 0 also away from that axis. So P prime is actually going to be right there also. So what is that point? It's negative 1, negative 2, negative 3, 0. So P is at negative 3, 0. And guess what? P prime is going to be at negative 3, 0 also. Now, where's L at? L's at negative 1, negative 2, negative 3, negative 4, negative 5, negative 1. Negative 5, negative 1. Left 1, down 1. Now, if it is going to fold over, it's going to end up right there. It's one space below the axis, so it's going to end up one space above the axis. This does not change. This becomes 1. Now, where's E? Well, E is also a negative 3. But let's see how far down it is. 1, 2, 3, 4, 5. Negative 5. Well, if it is, I forgot to write L prime here. If it is 5 below, then it's going to be 5 above. 1, 2, 3, 4, 5. And here is my image folded across that axis. This is E prime. And so what point is that? That's at negative 3, positive 5. Whoops, that looks like an at symbol. Close enough. All right, folding across the y-axis. Where's that y-axis? Right here. So z is going to end up over here, L is going to end up over here, and J is going to end up over there. Specifically, let's see, but it's folding over left to right. So, another thing is, you can just count. So Z right here is 1, 2, 3 away. So it's going to be 1, 2, 3 away this side. And J is 1, 2, 3, 4, 5 away. So it's 1, 2, 3, 4, 5 away. This is another way of doing it. And Z is going to, J, Z, U. U down here is also going to be right underneath Z. So without knowing any points, we can flip it. So again, there's different ways of doing this depending on how your brain processes it. So, where was J? It was at 1, 2, 3, 4, 5, negative 5, positive 1. Well, when it flipped, since it was 5 away on that side, it's going to be at positive 5, positive 1. The y didn't change. U and Z are both at negative 1, negative 2, negative 3. Okay. Z is at 1, 2, 3 above. And U's at negative 2 below. Remember, the y's aren't going to change, but it was left 3, so now it's going to be right 3 for both of these. And again, those points don't change. Okay, this one's a little bit different. Now we have a line x equals 3. So we have to find out where that is. Well, remember, that is a vertical line. X is always 3. So that's points like 3, 0, 3, 1, and so forth. So where is my line for that? 1, 2, 3. It's right here. That is my line, x equals 3. So that is going to be my line I fold over. And here's where actually the counting method is very nice. So notice how J is, well, if I drew it properly, J is on the line, right? Okay, well, that means J prime is always also going to be on that line. Now, let's look at H. H is 1, 2 spots away from that line. So it's going to be 1, 2 spots from that line here. Now, I'm telling you right now, this one's going to be a confusing one because a lot of stuff's going to overlay. Notice how H and S are both 2 away. They're basically switching spots. So this is going to be my H prime, and this is going to be my S prime. And remember, let's see, I can't tell what it is. I'm assuming that one's Y. Hoping that's Y. So this is also going to be my Y prime. Now where's J? Well, J is 1, 2 away this way. So it's going to be 1, 2 away this way. That's going to be my J prime. So when I connect these, remember that one's staying. It's going to look like that. It just basically swapped left side for right side. So let's see where those actual points are. Okay, so H is at 1, 1. H prime is at 1, 2, 3, 4, 5, 1. J, that one is at 1, 2, 3, 1, 2, 3, 4. So 3, 4. And that one stays the same for both because it was on x equals 3. Now, where is, S. So S is at 1, 2, 3, 4, 5, 1. They're basically just switching. So this is 5, 1. That's going to become 1, 1. Which makes sense. They just switched spots. And last but not least is y. Y, oh, wait a minute. My bad. I said J was Y. Sorry, bad printing. 3, 4 goes here, and 3, 4 goes there. J, which is at 1, 2, 3, 4, 5, 1 comma 5. Whoops. 1 comma 5. And the new J is at 5 comma 5. Sorry about that. Try that again. 5 comma 5. That was a tricky one because of the fact that, you know, it kind of overlaid on itself and it flipped over. All right, let's do this one. Where's y equals negative 3? Well, remember, y equals negative 3 is a horizontal line going through negative 3. So this time y is always the same. So 0, negative 3, 1, negative 3, 2, negative 3, and so on. So that's going to look like this. 1, 2, 3. You can kind of see a line already drawn there. There's my y equals negative 3. So now I'm just going to count to that line and go the opposite direction. So let's start at M. M is 1, 2 away. So it's going to be 1, 2 away here. So there's M prime right there. E is 1 below here. So it's going to be 1 above there. E prime. P is 2 below. So we're going to go 2 above. P prime. So we're going to connect those 3 points. And that has been flipped over that line. Y equals negative 3. So let's see where our points were. E was at negative 1, 2, 3, 4. Negative 1, 2, 3, 4. M was at 0, negative 1. That's an easy one. And P was at negative 1, 2, 3. And negative 1, 2, 3, 4, 5. Now, where are my prime images? Well, E prime is still at negative 4. Okay? But now it's at negative 2. M prime is still at 0. But now it's down at 1, 2, 3, 4, 5. And P prime is still at negative 3. That didn't change. But now it's at negative 1. Remember, if you need to stop the video anytime, feel free to do so. All right, so we need to plot these points first. Okay? So rectangle with these vertices. If you want to not watch me plot them and just fast forward a little bit, go ahead. So negative 4, negative 1. This time you're plotting, you're doing everything. You're doing all the work. So negative 4, negative 1. 1, 2, 3, 4, negative 1. 2, 2. 3, 0. And negative 3, negative 3. Okay? So here is my original rectangle. So E, F, G, H. And it says across the x-axis. So I like to draw in the x-axis like so, with some other color. Okay, a pen or another colored pencil. Now, let's write those down for, you already know them, but we already have them up there. So, new image. Let's just flip. Okay, so F. Well, first off, let's do G. G prime is the same spot, because it's on the line. F is 2 above, so F prime is going to be 2 below. H is 1, 2, 3 below, so we're going to go 1, 2, 3 above. so that's H prime. And then E is one below, so we're going one above, and there's my E prime, and then I connect my dots, and there is my flipped rectangle. And all I have to do is write down what those new points are. So E prime is still at -4, but instead of -1, it's +1. F prime is still at 2, but instead of being +2, it's -2. G is the same spot, 3, 0. And H is still at 3, but instead of being -3, okay, it's going to be +3. And last but not least, here we go. We're going to do one more thing. It's a triangle. Let's work. 3, 2. 1, 2, 3, 1, 2. Whoops. Love when that happens. Really? Okay, whatever. 3, 2. 1, 2, 3, 1, 2. There is my first point. You maybe don't see it. That's my J. K is at 2, -2. Right there. K. And L is at 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, right there. There is my L. So here's my triangle. Okay? Now, I'm flipping across the y-axis. Where is that? That's not there. That's just silly of me. The y-axis, everyone knows, is right here. So I'm just going to count from that point. So J is 1, 2, 3 away, 1, 2, 3, 1, 2, 3 away. There is my J prime. K is 2 away, so there's my K prime. And L is 1, 2, 3, 4 away, so 1, 2, 3, 4 away there. There's my L prime, and here is my new triangle, folded across that. So, J was at 3, +2. Now it's at -3, +2. K was at 2, -2. Now it's at -2, -2. And L was at 4, -5. Now it's at -4, -5. So the x's just became opposite. All right, so we have a rectangle here with vertices at -4, -1. That's E. And F, 2, 2. I don't know why I was going to put 2, 2 there. I'm going to put F. And then G at 3, 0. And -3, -3 for H. Yep. So H at -3, 1, 2, 3, 1, 2, 3. Here's my rectangle. And we're going to do it across y = 2. So y = 2 is a horizontal line at 2. So as we already had before, F prime is going to be at the same spot as F because it's on the line. So this is also F prime. Now where's G prime going to be? Well, it's 2 below the line, so I'm going to count up 2, G prime. E, I'm just going to count, 1, 2, 3, 1, 2, 3. And that's going to be my E prime. All we're doing is counting. And H is 1, 2, 3, 4, 5. And again, we're going 1, 2, 3, 4, 5. Not to the x-axis, but to that new line we drew in. So we're going to go up 5 from there. 1, 2, 3, 4. And it's going to actually be off the chart here. So H prime. And so there is my new rectangle right there. And if you visualize folding that over that line, that's what it would look like. So let's see what the new points are. So E prime is at -1, 2, 3, 4. 1, 2, 3, 4, 5. And F prime is at the same spot, 2, 2. No change there. G prime is at 1, 2, 3, 0. That's easy enough on the axis. And H prime, we're going to count it a little bit off. 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7. -3, 7. That's the new location. Okay, last one of these. This time we're going to be going across an x equals line. So 3, 2. 1, 2, 3. This is good practice for plotting points. J. 2, -2. Down here. That's K. And then L is at 4, -5. 1, 2, 3, 4, 5. Okay? And that's L. And there's my triangle right there. Now, I'm going across the line x equals -1. Where is that? It's a vertical line at -1. So now all I'm doing is counting. J is 1, 2, 3, 4 spots to the right, so I'm going to go 1, 2, 3, 4 spots this way. J prime. K is 1, 2, 3 spots, 1, 2, 3. There's my K prime. And L is 1, 2, 3, 4, 5. We're going to go off the chart again. 1, 2, 3, 4. No, we're going to be right on. There's L prime. And my triangle is right there. Now, where are my new locations? Well, J prime is at -1, 2, 3, 4, 5, comma 2. 5, comma 2. My bad. That's -5, comma 2. That's pretty silly of me. All right. Now K prime is 1, 2, 3, 4, 2. So -4, -2. And L prime is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. -6, -5. Almost finished. Translation, just remember, equals a slide. Okay? Graphing lines. X equals a number is a vertical line. And Y equals sorry, my bad. X equals, vertical line. And Y equals a number is horizontal. Sorry to turn around in my own head. Horizontal. So X equals looks like this. Y equals looks like that. And Y equals X is a slanted line. Like that. And that's it. There you go.